Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 7-3, Proving the Triangles Are Similar. Here's some of the information we're going to be covering today, which should go in your notes. Just some quick background information to remind ourselves. We've done congruent triangles already, and there are 5 ways that you can prove that triangles are congruent to each other. There's side, 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 or SSS. And then we also have side, angle, side, angle, side, angle, 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 side, and hypotenuse leg. So those are the 5 ways you can prove that triangles are congruent to each other. And then with regard to similarity, similar figures have the same shape but different sizes. And they all have to have proportional sides and congruent angles. To begin with our theorems today, we're actually going to start with side, side, side similarity. What this means is that if you have all 3 sides of one triangle that are proportional to all 3 sides of the other triangle, then you can prove that these triangles are similar. The similarity statement does need to make sure it's in proper order. Remember, the first one needs to be similar to this first one, the second to the second, and the third to the third. So that is important. But they have to be proportional, meaning that these all have the same ratio, the orange triangle to the greeny blue triangle. And for SSS, it has to be all 3 sides. The second one we want to cover today is for side, angle, side theorem. And it is important to remember that the angle has to be between the 2 sides in order to use side, angle, side. So remember, for similarity, the angles have to be congruent and the sides have to be proportional. So on these down here, notice that angle B here is congruent to angle E. So there is our congruent angles. And then our sides that are around the angle, so BA and DE would have to be proportional, and BC and EF would have to be proportional in order to prove these triangles are congruent by side, angle, side, because the angle has to be between the 2 sides. And then our last similarity is for, the only new one is for angle, angle. It wasn't enough to have 2 angles only if you're proving triangles are congruent. But since now we're only proving that triangles are similar, it is enough if you have 2 angles of one triangle that are congruent to 2 angles of a different triangle. You do have enough to prove that those 2 triangles are similar. And then the last piece of new information is on indirect measurement. If you've ever stood somewhere and wondered, gosh, I wonder how tall that building is I'm next to, or how tall that tree is, you can use indirect measurement to figure that out. So you use similar triangles to find distances that are difficult to measure directly. For example, we may not know how tall this Eiffel Tower is. However, we will know how tall we are. And if we put a mirror down here on the ground and look at the top of the Eiffel Tower through the mirror, we now know how tall we are. We know how far away we are from the mirror. We can measure how far away we are from the tower, and we can use similar triangles to figure out how tall the tower is. You can also do this using shadows like they do in your practice. So for example, I wouldn't want to climb up this cactus to find out how tall it is, but if I know that I'm 6 feet tall and that I cast a 4-foot shadow, I can use the shadow of the cactus to figure out how tall it is by using a proportion. And remember, it's very important in proportions that you keep it consistent. So you can start with whichever of these 4 you want. It does not matter. Let's say I want to start with my height. So we'll put me on one side and the cactus on the other. So if I put my height of 6 feet over my shadow of 4 feet, I have to do the same for the cactus. The height of the cactus over the shadow of the cactus. And again, you can mix those up as long as you're consistent. Then you'll use the cross product property to solve for x. And what you get is that the cactus is 13.5 feet tall. Here's another one from your practice. Explain why the triangles are similar, and then they want you to find the value of x. So notice what they've given us here. They've given us 2 sides and 1 angle. So this angle here and this angle here. Notice, however, it's very important that this angle on the big triangle does not have both sides around it. It only has one. Therefore, side angle side isn't going to work. And since we don't have this side here, side 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 also isn't going to work. So the only option we have left is angle angle, but they've only given us one angle. However, if you notice here in the center, these two are vertical angles because we have intersecting lines and they're across from each other in intersecting lines. So these are similar by angle angle. Then we can solve for x by creating a proportion. Remember again, it's important to be consistent. So I'm going to start with the outside here of my small triangle, and I can put it over the outside here of my large triangle. And then I can set that equal to the side of my small triangle over the side of my large triangle. And then I can use my cross product property to solve for x. And what you get is 125 over 6, or 12 5/6. So when you go to do your work, you're going to choose choice A, since that's AA, and then you'll type in 12 space 5/6 for 12 5/6. And then our last one wants us to find the value of x in the triangles below. If we assume that these are similar triangles, you can set this up a variety of ways. You just have to remember to be consistent. So we have the small blue triangle and the large green triangle. Since x is on the bottom of the large green triangle, we're definitely going to want to use the bottom of the blue triangle as well. So here's 17 over x, and then you can choose the left side or the right side. It doesn't matter. So 17 is the bottom of the blue triangle. I'll use 12, the left-hand side of the blue triangle, and x was the bottom of the green triangle. I'll use 20, the left-hand side of the green triangle, because 8 plus 12 is 20. And when I use my cross product property to solve, I get that x equals 85 over 3. So when you go to write that in your answer, it's 85/3. Good luck, everybody. I hope you guys do great.